All right. So this is the short answer, particularly the short answer focused on the eye and the colors that we see from the eye. There'll be more on the eye later on in the review guide, but this is just kind of the initial kind of how do we fix the eye, nearsighted or farsighted, and then how do we see the colors we see, and then what colors would we see. So first one, how would I fix this? So you could try and memorize it, or you can just think about what you want to do with the light. So look at it, and it's showing you what happens when parallel light comes into this particular eye. Now, this eye is a nearsighted, which means I believe it means it can see things up close, but when things are far away, they are out of focus. So nearsighted means you can see close but not far. And so what's happening is the light is focusing from parallel, is focusing too close in. It's not focusing here on the back of the eye, it's focusing right here. So we want to, and this is how you figure it out, we want to diverge it a little more. We don't want to converge it more. That would move it up in here. We want to diverge it to move that focal point back this way. And so we're going to use a diverging lens to diverge it a little more, and now the light would focus and then back here would focus back there a little bit more. So we would want to use a diverging lens to fix this particular situation called nearsightedness. If you wanted to fix farsightedness, which is where it was backwards, you want to diverge it, or excuse me, converge it sooner, so you'd use the other lens. All right. So color vision, how can your eye see yellow photons? If we only have red, green, and blue cones, how do we see the color yellow? Well, yellow, as we can see right here, is right in between the red and the green. Obviously, that's where it falls on the spectrum. But it's going to activate a little bit, not completely. It's going to activate the red and the green cones there. So if both of those are activated the same amount, then your eye assumes that it is yellow. So here, we'll pause, we'll write this, right? And so by activating both the green and the red cones. So how do we see yellow? By activating the red and the green cone. All right, so let's go a little bit further and say, well, how does television and phone screens use just RGB to show us all the different colors of light? And it's similar to this. Rather than yellow light, which is actual light activating two cones, the screen is just going to activate two cones as well, but it's going to do it with both red and green and blue light. So I'll pause that and put that in the work. All right, and so there it is. By activating the cones at different amounts, we see different colors. A great example of this, I mean, the other ones are all there, but a great example is that color magenta, right? Magenta light, that pink color, that magenta light is red and blue being activated together. Red and blue is magenta. All right. So then we get into the different colors that you would see. So for the subtractive color, remember you want to absorb one of the colors. So we're still going to stick with the whole. We're still going to stick with the whole red, green, blue light coming out there, and then it's going to hit an object. So I'll start kind of drawing these in. So what color does magenta look? Well, you want to think about the blue. I don't think I have a magenta color here, do I? There we go. Now I'm all set with my colors here. So white light, right? That white light sends off a red, it sends off a green, and it sends off a blue. Now it sends off all the others too, but then we can think about it through just these three colors. Then I've got magenta, right? So magenta is going to absorb green light, and it's going to reflect the blue and the red. So those are going to be reflected. But then it's asking what color it looks like through yellow sunglasses. So we have a yellow filter right here. So this yellow filter is going to absorb blue light, and it's going to let through red and green light. But I don't have green light already. And so the only thing that's going to get through that is the red. The blue is going to get stopped. And so the eyeball there, your eye is going to see red. All right? Again, red. Then we're left with red and blue. And then it's just red that comes through. So it's a step by step. You got to think about each of the different steps there to figure that out. Now you can also do it using kind of a mathematical way where you do like the light, the object, the filter, and then you get the total. So let's try that. Again, we need R, G, B for each one. R, G, B, R, G, B, R, G, B. Okay, so now we're going to step through this and cross off each of the things. So what color does a cyan ball look like when viewed through green sunglasses? So we have a cyan ball through green sunglasses. So I'm going to go through and I'm going to scratch off each one. So the light, well, the light is all the colors, so I can't scratch off any of those things. The object absorbs red. Cyan absorbs red, and so it gets rid of red, but it gets rid of red all the way down. So there's no more red light coming off that ball. We then look through a green filter. Well, a green filter absorbs red and blue, so that gets rid of the blue and the blue. And so now I can see that I'm left with green color, right? So you can do it kind of visually, like the duck simulation, or you can do it with kind of a math model. So let's look at the last one here. What color does a yellow shirt appear under cyan light? No, so no filter now, but it's under cyan light. Well, if you think about cyan light, let's use this one. Cyan light is blue and green light. Then I've got my yellow shirt here. So my yellow shirt is going to reflect red and green light, but there is no red, so it's only going to reflect the green light there. And so my eye, if you look at a yellow shirt under cyan light, it's going to look green because there is no red for it to happen. All right, hopefully that was helpful, and we'll get into the problems in the next video.